Good morning. I'm Dr. Cynthia, Computer Science Engineering Department, Kumaraguru College of Technology. Today we'll see about internetworking between wireless LAN and 3G network. What is wireless LAN? We have already seen in the previous topic. Wireless LAN is a small network which is set up within a small radius ranging from 30 to 300 meters. Probably we can use a WLAN to connect our home devices or devices within our office within a short range with the high data rate. It uses unlicensed spectrum, and when we use wireless LAN we'll be having our wireless LAN access point. So this access point will help us access to the external network. Now let's compare wireless LAN with our 3G network. So when we are using our mobile phone, we'll be registered with our 3G or 4G or 5G network. For now, let's take it as 3G network. So we are using our mobile phone. We are using our 3G cellular network, and when we are at home or office, we are also connected to wireless LAN through the access point, and through this 3G and wireless LAN, we would like to connect to our IP network. So what is the difference between wireless LAN and 3G? We know that 3G has got well established voice support, whereas wireless LAN, it can cover only a small area. It provides high data rate, whereas 3G can provide only low data rate. Wireless LAN, we need to have a hotspot or access point for covering or providing access to various units. In 3G, it is more suited to areas with low density demand for wireless usage. In case of wireless LAN, the mobility is limited. Probably we move from one room to another. In case of 3G, the mobility is higher. Let us see what is the objective of internetworking. What is internetworking? Internetworking is networking between various networks that uses different protocols, different devices, different systems, different location, irrespective of anything. Any device connected to any network must be able to communicate with any other device. So that is our motive. In case of you see this network, we have got our cellular network, we have got our home network, we have got our wireless hotspot, we have got an enterprise system. The user equipment or the mobile system probably will be connecting to this cellular network. Okay? So through cellular network we'll be connected to the internet. Otherwise we can connect our mobile phone to our home access point, and through this access point we would like to have access to the internet. So our laptop or user equipment, our intention is to connect to IP network to make use of our internet services. So what are the internet services? Our basically we want to browse data, we want to download a file. Okay, so we still use mobile phone which is connected to the cellular network. So what this cellular network is intended for? Mainly for you to talk over phone and provide some basic services, data services through our GPRS by sending SMS. But it is not intended to provide IP services. So you cannot use an exclusive cellular network to get the internet services. So the cellular network must be connected to an internet with the help of some gateway, so that the internet services are also provided to us. Yes? So that is the objective of internet networking. This 3G, we call it as 3GPP as it is the standard of our 3G network. So this 3GPP standard, they evolved 3G into 4G and 5G. So in general, we call it as 3GPP. So what are the basic requirements for internetworking? Yes, so we need to have some common billing and customer care. Yes, so if you can imagine this scenario, yes, so we are having our own mobile phone. Yes, so this mobile phone or laptop, it is basically connected to our 3G services. Yes, so 3G services, it is our basic cellular network. So for example, you are using Airtel for 3G. Yes. So what does this Airtel charge you for? The Airtel will charge you for its basic voice services. Yes. So or you have BSNL network, they will charge you for the basic voice and SMS services. In case you need to have the IP service. Yes, so this IP service, probably you can, your mobile phone also would like to have this IP service. So what are the alternatives? Your mobile can directly connect with the IP network and get its service, or your mobile phone can connect to your 3G network and your 3G network can connect to the IP network, and then this IP service can be provided to you. Yes, so in that case, the service provider for 3G and IP, they can be the same service provider or they can be different service provider. Whatever be the case, you need some mechanism. Yes, so you see, even if you subscribe to the same service provider for both your cellular service and as well as IP service, you do register for different plans. Yes? So for basic voice communication, you have one subscription, and for internet service based upon the bandwidth requirement of you, you are given some other services. So they have to take care of billing and customer care separately for your cellular network and separately for your IP control. So this 3G standard, it should keep track of access control and charging. Yes? So who is accessing what network, how long you are accessing. For example, I'm using BSNL service. So in case I have a separate wireless LAN access point in my home, for which Airtel is the subscriber. So when at home or at office, I use the wireless LAN access point. Yes, so I don't use BSNL. So normally I don't subscribe to BSNL for IP service. I use BSNL for basic voice service, voice and SMS service. So in case I'm going out of station, so I'm going to my native, in that case I subscribe to my roaming service of the cellular network, which is BSNL. So at that time alone I register, and for that month alone I pay extra to my BSNL service for getting the internet service. So it needs to keep track of the services provided, and there must be service continuity. Yes, so it is my option at what location I would like to connect to IP network through my wireless LAN access point. At another point I would like to connect to my IP services with the help of my cellular service. So it is up to me. Yeah? So it is up to my the service I subscribe to either choose wireless LAN or choose cellular for providing this. So I can go to wireless LAN, I can use wireless LAN to subscribe for IP service, or I can use cellular network to subscribe for IP service, or both IP and 3G, it can be the same service provider or they can be different service provider. However, the goal is to allow seamless service continuity. So I cannot have feeling that I have to move from one service to another, I have to change the service provider. So whenever I'm connected to wireless LAN, I'm connected to IP through wireless LAN. Whenever I don't have a wireless access point, I can be allowed to switch to my cellular service. And how this can be implemented. So in user point of view, it's my choice. In implementation point of view, is it really feasible to provide this internetworking schemes, yes, to connect this wireless LAN and cellular network, for which basically there are three different approaches which are used to provide this internetworking service. They are mobile approach, gateway approach, and emulator approach. Let us see each one. First, let's see about mobile IP approach. This mobile IP approach is called as loose coupling. So we have already seen what is mobile IP. In case of mobile IP, it will handle roaming between different networks. So you are roaming from your home network to a foreign network. Yes, so we are, in case of mobile IP, we saw that we'll be having home agent and foreign agent. So your mobile device will be having its association with the home network, and whenever you move to a foreign network, the foreign agent will communicate with the home agent to get your details, and the home agent is responsible for forwarding your packets to the foreign agent. And in case of mobile IP, we also saw that there is a problem which was called as triangular routing. So this mobile IP can be a solution. That is, wireless LAN can be considered as one network. IP can be considered as another network, and we'll use the same mobile IP approach so that we can handle moving from one network to another network, say wireless LAN to 3G to IP network. Let's see the architecture of mobile IP approach. You can see user equipment, which can be your mobile phone or laptop. You can see that here there is a wireless network. Okay, so here we do have our cellular network. Yes. So you will be having, your host can move from your user equipment can move from your 3G network to wireless LAN or wireless LAN to 3G in order to communicate with your host. Okay. So the ultimate motive is you need to communicate with the host to get some IP services. Yes. So you can see clearly in this diagram, this is our wireless LAN, this is our 3G, and this is our internet. So to get any internet service freely, your mobile device must be able to get it, whether it is in your 3G network or in your wireless LAN network. So you can freely roam between networks, for which you need the support of this foreign agent and home agent. So the hardware and software required for setting up of this home agent and foreign agent must be deployed even in your mobile network. You can see here there is a foreign agent. Yes. So you will have the home agent. See your IP network, there is a home agent. Yes. So your cellular network, it has got HLR. Yes. So we know that in visiting location there will be VLR. Yes. So you have got the foreign agent and home agent installed everywhere, so that there is seamless internetworking between wireless LAN, and this is called as loosely coupled, because we are not going to alter the existing architecture of our cellular or wireless network. Instead, we are adding some feature in by means of home agent or foreign agent, so that we provide the capability of internetworking. The second approach we are going to see is the gateway approach. What is a gateway? We have seen that when we change service providers, yes. So your one of the network, in case of IP network, you know that your network is say you are in India. Yes. So you are connecting to a different IP network which is present in US. Yes, so you are using TCP/IP network. Say in US they are using a different ATM or different type of network. Yes, so all protocols and services will be different. In that case, we will be having a gateway. So what is, application layer gateway? Yes, so this gateway will help seamless internetworking between different heterogeneous network that uses different types of network capability and infrastructure. Similarly, here also we will have a gateway which will take care of the responsibility of internetworking between the wireless LAN and 3G network. Yes, so what is the principle here? We are going to introduce a gateway node between the two networks. So this gateway node will exchange all the required information to forward the packet between roaming users from, say, wireless LAN to cellular network. Yes, so this approach will separate the operations of two different networks. Every network will have its own function as usual. We are not going to change the architecture. Instead, the gateway node will take the responsibility which is required for the seamless roaming capability. So what is the advantage here? That each network can operate independent of each other. See, this is the architecture of gateway approach. So we have got original wireless LAN network, we have got original 3G network. We are not going to modify either of the network. Instead, we introduce a node which is called as a gateway node, and this gateway will take care of roaming or movement or internetworking between these two networks. So when the user equipment moves from wireless LAN to 3G or 3G to wireless LAN and still want the IP service which from this particular host, it can approach the gateway. Yes, so if it is in wireless LAN, it can approach the gateway. If it is attached to the cellular network, then also it will approach the gateway, and this gateway will forward the packet between intermediate networks to the host, and from the host the service can be provided to the user equipment. And the next one is emulator approach. This emulator approach is tightly coupled approach. What do you mean by tightly coupled is you change the infrastructure itself. Yes? So existing infrastructure itself we are going to change. So that's why we call it as tightly coupled. We know wireless LAN, it uses an access layer. Yes, so we have got a wireless access point. Yes, and this cellular network is the 3G network which is working independently. Yes, so now we are going to change the existing architecture of wireless LAN or 3G network so that it has a built-in ability to support the network. That means say Airtel is the provider for both cellular and wireless LAN. Yes, so they themselves will integrate. The wireless LAN access point will be automatically integrated with the 3G cellular network. So that's why it is called as tightly coupled. Yes. So here the disadvantage of tightly coupled network is that there is no flexibility. Yes. So you cannot change the architecture. Yes. So when you want to roam to a different network, then the existing infrastructure itself must be changed. So that is the disadvantage here. Yes. So here the GGSN, that is a gateway GPRS node, will be a single point to the internet. You can see the emulator approach. See, we don't have any extra gateway here, or we don't have home agent or foreign agent. Rather, the capability of roaming, it is incorporated in the architecture of wireless LAN In case of wireless LAN, we introduce an RNC emulator which will become a part of wireless LAN architecture. In case of 3G network, again we will modify this GGSN itself to incorporate this roaming flexibility. Yes, so your node can move to any of the network. There is no need of any additional support from any other node. Instead, your infrastructure itself will support. Yeah? So you can see here the usually if you have wireless LAN, you have a separate billing service for wireless LAN. You have a separate billing service for your cellular network. Yes. So now the billing service must be integrated. Yes. So you see, if it is two different networks, both of them will have same two different billing service. But here you need to have an integrated billing. Yes, for both wireless LAN as well as the cellular capability. Let's see the IP connectivity between wireless LAN terminal and IP networks. So we have seen what is heterogeneity. It is connecting different networks, and here we need connection between wireless LAN and IP network. So if you consider IP network alone, we know when we are going to connect a terminal to the IP network, what happens? A DHCP will allocate a IP address dynamically, and suppose you want to get a service from a server, then you have the role of a DNS, where you will be resolving the URL to an IP address, and then we have a gateway address translation, and we have HTTP. You have a built-in AAA function of authentication, authorization, accounting, and we do have network management services and mail service. So for every internet service there are some requirements. Now if wireless LAN is going to operate separately, then how a wireless LAN operates? We typically have an access point, and whenever our terminal wants to connect to the access point, we connect with the access point by finding the address of the access point. We associate using the free spectrum we are going to communicate, and this connection is independent of any communication with the IP network. So we may have a different service provider for our mobile services and a different service provider for wireless LAN. But when you are trying to integrate it as a single network, so say we need to have the infrastructure as a tightly coupled one, then wireless LAN is also a part of IP network. Suppose you want to make the wireless LAN as part of IP network, then the entire scenario will change. Suppose you want to connect a mobile terminal to the wireless LAN access point, then every scenario that will happen when you connect your mobile device to a IP network must happen now. That is, you should use a DHCP server to allocate a IP address dynamically to the terminal which is being connected to wireless LAN. You need to incorporate the services of AAA. You need to consider your mobile terminal as another host. So implement the services of DNS, network management. Everything that works in IP must also work with your wireless LAN. Let's see about session mobility. What is a session? We have seen session is a transport layer connectivity between end-to-end system. So if you are having TCP, you will have a TCP session established. So your end-to-end systems, that is the source and destination, to whichever network they belong, once they start to communicate, they would have established a session. Yes. So when source and destination, both nodes are moving, that is they are mobile, this session mobility must continue. So what are the measures you can take to continue the session mobility. So session is defined as the flow of IP packet from end user across the network. So a mobile device is capable of connecting to a data network through wireless LAN and then to the cellular network. So your end device could be a laptop, it could be your mobile phone. So it is integrated with your wireless LAN, and then you do have the GPRS data services. So the end user is connected to the data network and is already in a session flow through one access network, which is the wireless LAN. Now you are connected to your wireless LAN and you move out of the coverage area of wireless LAN, because you know the coverage area of wireless LAN is limited. Yes, so when you move from one cellular network to another cellular network, when you roam from one area to another area while using your mobile phone, then seamless connectivity, even session mobility is integrated. But when you move from a wireless LAN outside to a cellular network, even then the seamless session mobility must be unaffected and it must continue without any user intervention. So how can you do it? It must be integrated in the system itself. Now, internetworking architectures for wireless LAN and GPRS. Now, what is GPRS? It is the data service of our cellular network. Okay? So, we have seen already what is tight coupling and loose coupling. Now, for internetworking between, we have seen internetworking between wireless LAN and 3G GSM network. The same thing has to happen for wireless LAN and data service, which is GPRS. So here again it can be either loosely coupled or it can be tightly coupled. So we have seen what is tightly coupled and loosely coupled. So in case of tightly coupled, the facility must be integrated in the core network. In case of loosely coupled, you introduce another interface such as a gateway node or any other referencing service which can take the role of this interconnection. Yes. You can see here that's the GPRS node. You have the serving gateway service node. So any additional functionality in case of loosely coupled, yes, so you can introduce a gateway at this particular point. Yes, so you have a special gateway node at an interface point, so that whatever service is required, the additional responsibility will be taken care of by the gateway node. The other option is tightly coupled, in which the services are integrated in the core network itself. You can see here the modification will be done to this interface, so that it will also handle the mobile node which is connected to the wireless node as one of its own node. Okay, so that is the difference, as we have seen previously. When you integrate, when you tightly couple a certain system, all features must be integrated in the core network. The additional features of AAA service or mobility, everything is already present in the system. If you design a loosely coupled system, then all the extra features must be incorporated in the additional gateway node. So what is the advantage of tightly coupled architecture? So we have seen that in both tightly coupled and loosely coupled, it has got its own advantages. So in case of tightly coupled, as I've told now, there is a seamless continuation. So only thing you have to make so many additions or changes to the existing infrastructure in order to consider your node which is connected to the wireless LAN as one of its own node. All other services are already present in the architecture itself. So that's the advantage of tight coupling. So to summarize, these are the differences between tightly coupled and loosely coupled system. You can see the authentication accounting service. So in case of tightly coupled, you reuse the services which are already available, whereas in loosely coupled, you will build a separate system which will have these services. So the mobility, again, in tightly coupled system, already there is SDSN which is taking care of this tightly coupled, and this will continue to take care of it. Now in case of loosely coupled system, you have to incorporate the features of home agent and foreign agent along with the interfacing node, so that it will take care of the mobility. Yes, so the session mobility or a context transfer, again it is already available in tightly coupled. In loosely coupled, the extent of context transfer, it depends upon the extent of service you have built into the new node you have incorporated. So the same thing with system engineering. So the impact of high speed network on existing cellular network will be an issue. Yes, so the speed, yes, so wireless LAN is a very high speed, yes, but the data range is slow. If you consider cellular network, the speed is low but range is high. Yes, so in case of loosely coupled, both are considered separately, so you need not worry about the variation in speed between wireless LAN and GPRS. New development, wireless LAN terminal modifications for GPRS signaling is required. So suppose you need a modification, the entire core network infrastructure which has already been deployed has to be changed. Yes, whereas in case of loosely coupled system, it is enough if you change the features in the gateway itself. And standardization, a new interface alone is required. Yes, so not major change. Whereas in case of loosely coupled, you have to incorporate the features of authentication and other authorization features. Yes, so the target usage in case of tightly coupled, it applies primarily to the wireless LAN network owned by cellular operators. So for you will suggest tightly coupled system only if the wireless LAN provider and cellular network provider are one and the same. Yes, suppose you have Airtel service provider for cellular network, and same Airtel has provides wireless LAN infrastructure too, then you can consider tightly coupled system. Yes, so otherwise you need to go for only loosely coupled system. So that's about internetworking between wireless LAN and existing cellular network in order to have a seamless access to your IT framework. Yes, thank you.